Thanks for having me here. I'm so glad to come to New York for this presentation. And thank you, Mark and Dennis, setting up the stage to talk about how we can make money in the AI time and how we build applications, essentially for one specific domain, conversations, how we build a really production-ready applications that people can use daily. I spent the last 14 years in the software development, AI space without knowing it, without noticing it. I first started consumer applications. It's kind of like news recommendation applications where you can share news that you like to read with your friends. And of course, with machine learning, try to predict what you like to read and predict what you want to share. And after that, there's some other startups in the space. Try to build teams, try to build products that create this kind of cool applications. At that time, it wasn't that cool to call the applications AI. AI was kind of like a long-term word, right? Invented 50 years ago in research, AI. And then it somehow hit the snow period where no one's talked about AI. Until recently, everyone's talked about machine learning and AI applications. So now we're again. But the idea is that we want to build smart application. And when I see all the teams, all the products that we try to build, it was hard. It was really hard. And then I have a thought one day. When we build search, when we build database application where you just store your data and you want to search some information, what do? You pick up some algorithm and you build the whole data storage, file system, you create the search indexing technology, and then you build a 100-people team to build a database server before you build your website. No, you didn't do that. You just download the database server and then you use it. It's just like 5 minutes work, right? And there's a company going IPO, New York-based company. It was IPO actually recently, database company, which is great. So the idea came where, why do we need to do it? Why do we need to recreate the whole AI or machine learning server from scratch for every single project? So we invented PredictionIO, an open source machine learning server. Obviously, we try to mimic the successful story of a lot of open source database businesses, right? We created it open source, and we hope everyone can contribute to it, and we create something that is useful for production to build smart applications. And we made it. PredictionIO became one of the most popular machine learning projects, and it's used by thousands of companies. And the company was acquired by Salesforce, and I'm leading the Salesforce Einstein platform project on the product side right now. So Einstein is the AI initiative, and the Einstein platform, we power all the AI applications in different verticals in Salesforce. So that's the background. And today I want to share just one thing, the journey. Given all these years, starting from scratch, trying to create a server, create a platform, and now running Einstein, every time we make one baby step, we thought, OK, we're done. This is the one problem we need to solve. And turns out it's a big journey. Just like baby learning how to crawl, learning how to walk, then learning running, he or she doesn't know what's coming up next. But then it becomes a long life journey to pick up new skills, and then you move forward. So that's what I'm going to talk about. And just a very quick background. Machine learning is about getting data sets. Mark talks about having great training set data set. That's your golden mine. If you have some proprietary labeled data set, you can train a really powerful machine learning model or deep learning model. And then you can classify data, and then you can have data that you want to classify, then you make prediction. It is just that simple. That's machine learning. That's teaching the computer how to learn to predict, which translate technically to 3 lines of code. It's not a technical talk, but I think this 3 lines is very useful. And surprisingly, the previous speaker talked about Scholar, how cool it is, the team built in Scholar. And it looks like a Scala language. So the first line is read from a data set. Second line is you build a prediction model with one of the algorithms existing in the market. And then now you have a model. You run the for loop. You try to make predictions, right? For everyone here, we want to predict what you like. So that's the most basic machine learning or AI or recommendations applications that you see in textbooks or in any tutorial. So you download any machine learning tools, that's probably the first tutorial you want to learn from. And we feel like, OK, that's it. We know how to build AI. Now, that's the real thing. First step, building applications, real application, machine learning application. The first thing we learned is the biggest challenge is how to be stable. Now we download machine learning libraries. There are tons of them nowadays. Like you don't really need to worry about not having enough algorithms. There are a lot of open source, not open source libraries that you can use. But how do you make it stable? 3 things I learned. Of course, there are many things, but 3 things that are most important. One is garbage in, garbage out. Your data is super important. And having a healthy, stable data pipelines, really, really important. I can give you an example. We have a team back then built a system for customer, and then we figure out the parameters, we figure out everything is fine, and then we launch it on production. What's next? Classic scenario, right? The next day, data is not flowing in, or some crappy data flowing in the system. The model is screwed up. The beauty or the interesting thing about machine learning is it's a live system. It's not you deploying something static and it keeps it like that. It's a machine learning system that keeps learning from new data, meaning you need to deal with new data, meaning unless you want to dedicate people to look at every single new transactions of data going into the system, it is automated. You better have a really robust system to make sure that you're pulling the right data, do sanity check, make sure you're not pulling in the wrong data or corrupted data, make sure you're actually processing the data, run some statistics and metrics to monitor it 24 hours a day systematically, make sure you're storing the right data because you don't know what data you will need in the future, make sure you handle problems like real-time changing data as well as batch update of the data. So turns out when we think we're building machine learning applications, we're building the very robust data pipeline. So that's the learning number 1. Learning number 2, if you guys are software developers, how many of you actually use the code software release process? Like you have development environment, test environment, release environment, production environment. So if you all have this release process for software, you also need that for machine learning. That's not what you see in tutorial in textbook, but remember, your models keep updating every day or every hour, or even in real time sometimes. If your models keep updating and you're serving your production customers, imagine if you're a bank, you have a risk model. You're determining whether you want to loan some money to your customers. And this is the model that affects people's life, whether people can buy a car, whether people can buy a home. And then if you're not monitoring the release process, you're not really that responsible, right? You monitor your software release cycle. You have to monitor your model as well. So we see more and more companies coming up and provide model management system. This is a great area that I believe that we need more companies, more solutions in it. How do you monitor, how do you manage the model process? If something goes wrong, one button, you need to reverse it to the old versions. And you also want to keep track of a number of things. The source code that has been changed, the data snapshot that has been changed, and whether the algorithm has been changed. So you can debug it, just like any regular software development process. And the third thing is, machine learning models or AI algorithms oftentimes give you a score, but you don't show the score to customers most of the time. Like if you're building something to recommend music to people, you don't say, hey, this music score 0.56 and that's 0.95. That doesn't make sense. And usually we need to combine score with real-time context. You don't want to sell the product that no longer exists. And if you happen to go to San Francisco, you want to see the meetup, the events that's available in San Francisco and not in New York. So combining real-time context into the AI applications and make that scalable, that is important. All of the time, we focus on the scalability of model building. How many GPUs do you have? How do you process the data? But in real time, when the query hits your system, and when 100,000 people using the system in real time, it's not just the score, but also the layer combining with the score. So that's the hard lessons we learned in the process. 3 things. Now we have a really cool applications on productions after solving all the stability issues. What's next? People are greedy. Even though we try to focus on solving one problem, when we work with customers, when they see some success in the email campaign, it's become smarter. They want to make other parts of the business smarter. There are many, many places you can apply AI in your business. Sales, marketing, service, security, analytics, HR, finance, everywhere. Then people will say, hey, we really want to build multiple applications. We have the same data source, or we have some external extra data we want to add into it. But at the end of the day, we want to build many applications. Cool. Just clone the project and rebuild everything. No, that's not what you do in the software development world, right? Unless you're doing prototype, that might make sense. But we really want something that is reusable. So that's the next stage. After you can crawl, you make things stable, you start to walk. Is to make the development of AI reusable. Font is a little bit small, but let me read it out for you. As a machine learning developer, there are 2 things I want. Reusability and pluggability of components. Less code, less boilerplate. Maintainability of multiple applications. The principle of not repeating yourself. Very, very creative, very important statement, which you have seen in the last 100 years already. Essentially, if you have been building software, that's the promise provided by software development framework. Like if you use Python, it's Django. If you use JavaScript, that might be like Node.js, React. Essentially, any software development framework provides you with this software design pattern reusability. And we just need the same thing in machine learning development. So take a deep breath, and then we look at every project we created. There's some common patterns we discovered. Read training data from the source. Again, training data is very important to build machine learning model. Prepare the data. So you need to extract information from your data, like what's the features. If your raw data is an address, maybe the distance is the real data that you want to put into the model. Maybe it's something else. Train the model, find the best model. Now you have a model, you need to serve what we call query. Essentially, tell me if this application is a fraud or not. That's a query. And then you want to serve the prediction result. It's yes, maybe, no, or like a level of it. How do you want to serve it? At the end of the day, you also want to evaluate the model as well, right? 99% of the projects, machine learning projects, AI projects, follow this pattern. So cool. Just put some framework around this. And at PredictionIO open source, by the way, we after the acquisitions of company, we have donated the open source part of PredictionIO to Apache. So you can use open source Apache PredictionIO just like you use Apache Spark, Apache Hadoop. So that's the MVC model view controller equivalent for machine learning that we have created. D, kind of cheating because D stands for 2 words. Data source, data preparator is D. A is algorithm or algorithms. S is serving, is the real-time logics serving layer. And E is the evaluator. So in every single component of that, you can reuse them. Let's say you're building, simple example recommendation again. You're building one recommendation engine in your email, one recommendation engine on your web front page. In the email, you might just want to show 3 latest products and recommend them to your customers. On the front page, that might be more personalized based on what they have purchased before, and then you personalize that. So one with time, one without time. You can share the same data source, data set. You don't need to rewrite all this stuff, right? You're reading from the same data. You might be using a different algorithms, or you might be using some different real-time logics. This creates the separations of concerns where maybe one of your teams can work in the data preparation, other teams or multiple data scientists or data science team can create different algorithms. And later on, you can compare to see which one is the best. Some team might be good at evaluation, statistically see how good the engine is performing. So this creates a framework. This is just one example of framework, and PredictionIO pioneered that. But I believe that's another area where if you guys are looking for area to participate, to contribute, I believe that we need more machine learning development framework like that. There's pros and cons for this model we created at PredictionIO. Very strict, very clean, but it's not completely flexible. So just like software development framework, there are more different flavors for different projects. I believe that more people, more companies will create different machine learning frameworks in the future. So that's PredictionIO. One server, you can create multiple engines, same data source. And the results of that is very powerful. Now people, the community, if you are expert in sentiment analysis, you can create a sentiment analysis template with all these components and share it open source. Other companies, they can pick it up, just modify maybe the data source part, or maybe add it with their own algorithms, and then they can customize it. If they don't want to do any of that, they can just download your template and use it as is. So at PredictionIO, there's a vibrant open source community with ready-to-use applications that you can download. There are many, many other things you can make it reusable, feature stores, metrics, how do you run experiments, algorithms, and many, many more. And I do hope to see more collaborations among different communities, either through open source or maybe through some galleries or collaboration. I think that's the future. So, you know how to crawl, you know how to walk. Next thing is really running. And that is very interesting for me because several years ago when we were creating PredictionIO, we thought, oh, that's the perfect model. Now we make it stable. Now we make things reusable. That's the journey. Not until I saw companies like Salesforce, where they have 100,000 customers, and we see the need of automation. Why? Simple math questions. How many data scientists do you need when you need to build custom model for one customer? How many people did Dennis said in his company? 150 people, 100-something people, right? Then how many people would they need if they need to build not just one X.AI applications, but maybe 10 different X.AI applications? 1,500? How about you want to build, how about if your company is that you need to serve 200,000 unique customers running different business, having different business problems? The answer is not scalable. So there are really a lot of processes that labor intensive in the AI development process. And that's why Dennis kept saying like their company is still small even though they have over 100 people. Like pre-process data, collect the data, pre-process data, select appropriate features, choose the appropriate algorithms, tune the model parameters. After you tune the parameters, you need to tune the models and then evaluate the results. Every single step, there are many more of them. Interestingly, we always say AI replace people, but every single step is labor intensive. We need a lot of people in that. It just isn't scalable. Think about companies like Salesforce. When we launched predictive lead scoring, just an application that predict who you should call first in the first thing in your day. We have small companies like flower shops. We have large companies. We have like telecom company, financial company. Every single one, different data set, unique data, different size of things. They need different things. How do we have so many teams to clean the data, to choose the algorithms for every one of them? We can't. So that's the beginning of AutoML, what we call automated machine learning. The idea is actually very simple. Each customer has unique data set. And then for every one of them, we tried different methods to process data, tried out different algorithms, and automatically find the best one. So that's the oversimplified idea behind AutoML. Of course, it involves a lot of statistic mathematics model to make it more efficient, because unless you have unlimited processing power, this is very, instead of human resources intensive, it's now computing process intensive. So we're changing the human scalability problem into a mathematical problem. How do we solve this problem efficiently mathematically? And this is a super exciting research area. So if you're into the math, into statistics, I think the industry really need more people in this area. We need a lot of solutions and maybe startups, maybe products in this kind of area. So think about it if you're those kinds of math mind. If machine learning is about teaching computer to learn, automated machine learning is about teaching the computer to learn how to learn. One last thing is, you know how to walk, you know how to run. Everyone has the same dream when they were a kid, looking at the airplane and they want to fly. And by wanting to fly, by flying actually means you give the flexibility, you give the freedom to your customers. Let them build on your platform. Mark mentioned Watson is a platform. It's not just one product for one solution. It's a platform. You can build on top of it. So the keyword is be self-served, which actually built on top of previous steps, right? Of course, we don't expect every company to have sophisticated teams, resources to build like a huge data science team. But with the technology, like robust data pipeline with automated ML, we're making it very easy for every company or even every individual to build AI applications. Several examples, the different way to do it. It's actually not an easy solution. At PredictionIO, we tried years and years. Well, sounds like a long time, but actually we did spend several years trying out different models to see how we can enable developers to build AI. One is the API. The new word is API, as people say it. At Einstein, for example, we launched Einstein.ai. You can create sentiment analysis, vision detection, things like that with the API. As it suggests, it's very developer friendly. You just input your data, select the model, and then you extract predictions. You don't even need to write the modeling code. That's one solution. But some people might want something more flexible or like easier to use than API. They might want something point and click, right? Visual. At the very early version of PredictionIO, we have something like this. If you need to build a recommender system, you don't need to write a single line of code. You just point and click, that's what I want, that's the data I need, and then you can create prediction. And of course, some developers, they really, really want extreme flexibility. And nothing is more flexible than giving them access to your source code, to your GitHub, make the project open source. But the thing I really, really want to talk about is this line. One hand is simple, one hand is flexible. When we create a product, when we make it super, super simple, talk to customers, talk to developers, most of the time they will ask you, hey, but how can I integrate my own R model into it? This is so simple, but how about I want advanced features? And then we make it very flexible. Everyone can create their own custom algorithms. And then there will be other groups of people who say, OK, that's great, but I want to build something in 3 minutes. How can I do it? So the learning I got is actually there's no perfect solution, which is the beauty of our technology world. There's so many solutions. There's no one-size-fits-all solution. So at the end, at PredictionIO, we took the very, I would say, interesting approach. We make it super flexible with the design patterns, so you can create anything you like. But we also create a template gallery, ready-to-use engines built on top of the flexible system. So people who want to use it as is, they can just download it and use it. Data scientists, if they want to tweak algorithms, if they want to create their own evaluation metrics, look at the source code. It's open source. You can customize it and share it with the public. That's the approach we took at PredictionIO. And for Salesforce, we have quite different customers, right? Business customers. So we also have a range of products. It's not one product for everyone. We have a range of products on Einstein platform for them. But the learning is really, even though it's a hard problem, give them a platform. Every time I see very impressive, successful cases created by our customers, they always exceed our imagination. So that's what I wanted to share. Crawling, walking, running, and flying. That's the journey. Not sure where you guys are at, but I still feel that there are a lot of opportunities for developers, for startups, for companies to participate to disrupt this market. Thank you.
Questions, Matters will bring the mic to you. Please raise it.
All the way in the back, guys.
I start here.
So I had a question. So I had a question about your.
Are you safe there?
Probably.
Okay.
I'll hope. I had a question about your AutoML point. So actually, two questions. One is just if Einstein.ai actually offers an AutoML API, and the other piece is if you could talk a little bit about how you guys went about doing it. Is it just purely grid search? Did you try to train a neural network to do it? Did you do how do you optimize the data sets as you apply different models, et cetera?
That's a great question. So repeat the question is, one, do we do AutoML in Einstein.ai, the API services? Two is, are we actually doing AutoML or is just like research at this stage, basically on Einstein? Einstein.ai is a combination of many services. So we have visions, we have text, we have language, we have different things. So sometimes there's pre-built model. You don't need to retrain your own model. Essentially, if it's like object detection, there's something pre-trained already. And we also allow customers to upload their own data set. So there are a lot of interesting cases where people want to recognize what's in the refrigerator, so they can upload their own data set as well. One more interesting example is there's sentiment analysis, which usually when you say it's a hot product, it's positive, right? Your Watson is hot, like Einstein is hot, the products are hot. But that's one customer, they sell air conditioner. So your air conditioner is the hottest on the market. That's actually not a positive sentiment. That's quite the opposite. So we allow customers to upload the proprietary data to retrain the model, and the system automatically train the model for you. So you don't need to select, tune the model, train the model. So yes, it's automated already. And in the broader sense, in Einstein platform, AutoML is not just research. We need, as I said, we need that practical. We just cannot afford to build a unique lead scoring model or personalization model for every company. So we're running the AutoML daily. We spend a lot of resources, and we'll continue to research and develop on this area. So we're looking for more people on that area as well. Thank you.
So one of the slides you showed a template gallery of various data science pipelines, I think, centered labs and so on.
Sorry, I didn't catch it.
I think in one of the slides you showed a bunch of templates of various data science flows. Is that part of PredictionIO?
Yeah. So the question is that I show a slide about different template. So if you go to Apache PredictionIO, there's a link called templates or template gallery. There are a bunch of them. We could not list all of them because we realize it's a global project. There are different people building stuff. But you can just go and download or customize some of them.
Thank you for the talk. I just have a quick question. So as we all know that when the machine learning algorithm actually used in business, you have those positive, false negative, known as type 1, type 2 errors quite high. So how are you going to convince your customer who are using your machine learning algorithm in those scenarios?
That's a great question. So I would summarize it. Actually, how do we convince customers the model we built are good, right? Remember Dennis talked about low accuracy, high accuracy. I think, and more scientifically, what's your point? Like true positive and negative. That's a hard problem in business. Like we can use very sophisticated mathematical metrics to say your ORC score is such and such, or your RMSD is such and such. But that numbers may not make sense to some customers. Like when they look at the numbers, well, what does that mean? Is it helping our business? Is it like helping us save time? So another area that I did not mention, which we're actively developing, is evaluation, dashboard, explainability. And I believe that one area in machine learning research is explainable machine learning. That is super interesting and valuable in the business world. Like, I create a model for your business. Why? Why we make this decision? Why is it accurate? And more importantly, how much have we helped you gain more or like save? Like we usually don't want to go into the cost saving side, but more like what's the business benefits we have provided. So this is another expertise in the area. Like maybe it is visualization, maybe it's human-computer interactions. How do we interact? How do we help the interaction between end users and the model? So a big area.